Well, let's look at the ChemQuest gas and molar volume problems, and did the first four. And let's look at problems number 5, 6, and 7. So we can use the ideal gas law here, PV equals nRT. And remember, excuse me, if we got something that has a molar mass or mass, we can separate moles out into the molar mass and the mass of the gas. So I have M, which is molar mass, PV equals the mass of the gas, and RT. So let's look at this problem here. And again, if we want to write our data table out, volume MRT. Some oxygen gas has a volume of 41.0 liters, so we know this is 41.0. A pressure of 245, a temperature of 279. We know R for kPa is 8.31. And what is the mass of the gas? We don't know that, but we can figure out the molar mass, because oxygen is one of the 7 diatomics, so it's O2. So therefore we have 2 O's, that's 16. So that is a molecular mass, molar mass of 32. So now we can go ahead and plug in. So 32, and we're going to use this formula here. Pressure is 245. Volume is 41.0. We don't know M. Let's see if I get a little room here. R is 8.31. Temperature is 279. So we can go ahead and do the math here. And let's see, where's my calculator? As we crunch out the math on this particular one. So we have 32 times 245 times 41 equals, divide by 8.31, that equals, and divide by 279. Divide by 279 equals, so we have a mass, and again, looks like we got to use 2 sig figs here from the 32, and we can call it 140 grams. So that's problem number 5. Let's look at problem number 6. Got 175 milliliters of oxygen. We're collected at room temperature and 100.2 kPa of atmospheric pressure. How many moles of oxygen gas were produced? Alright, so here we're looking, we want moles, and we got a mass here. So let's see what we have here. So we can, again, see we got mass, we got to use the formula for this particular one here. We got, oops, I guess we don't have to on this one, my fault, because we are looking for moles, so we can go PV equals nRT. Have a double take on that one. Alright, so pressure is 100.2. Volume, well, we've got 17.5 milliliters, and that's got to be in liters. So we know that there are 1,000 milliliters in 1 liter. So if we go ahead and divide 17.5 divided by 1,000 equals 0.0175 liters. 0.0175 liters. So we've got that. N is what we're looking for. R is 8.31. And temperature is 22C. We know Kelvin equals C plus 273. So 22 plus 273 equals 295. Alright, so let's go ahead and plug that in. P equals 100.2. V is 0.0175. We do not know what N is. R is 8.31 and T is 295. So if we go ahead and do the math here, and we go ahead and calculate that out, we get N equals, so let's go ahead and multiply that out, 100.2 times 0.0175 equals, we're going to get a pretty small number, divided by 8.31 equals, divided by 295 equals, and it comes out to be pretty small, 0.000715 moles. And it looks like for sig figs we could probably use 3, so that looks pretty good. So we're all set there. So let's look at B. What is the molar volume of oxygen gas at conditions in the laboratory? So what is the molar volume? So we're going to assume, seeing it says molar volume, we're going to assume N is going to equal 1. And also you got that from the reading from the previous pages on here. So PV equals nRT, and we're doing that up there, conditions in the laboratory, so we're assuming it's that up there. So pressure equals 100.2. We're going to assume we want to know our volume, so we don't know that. We know N equals 1. We know R equals 8.31, and we know temperature is 295. So P 100.2 times the volume equals 1, and let's call that 1.0 so we can get 2 sig figs out of this, times 8.31 times 295. So if we go ahead and do the math there, volume equals approximately 24 liters. Let's go on down to number 7. What is the molar volume of a gas at 135 kPa in 45 degrees Celsius? So N again is going to equal 1. So we have our formula, PV equals nRT. So pressure is 135. Volume we don't know. N equals 1. R equals 8.31. Temperature, again, temperature is Kelvin equals Celsius plus 273. So 45 plus 273. Oh, I think I'm off the page. Excuse me. 45 plus 273 equals 318. Alright, so pressure 135. We don't know the volume. And again, let's use 1 here. 8.31. And temperature is 318. So if we go ahead and crunch a number here, it comes out to be about 20 liters. Alright, so that's what we have for this.